If I asked you to picture a modern day city, what kind of things would come to mind? Maybe towering buildings and freeways sitting on pillars of cement, apartment complexes and suburban houses built way back in the 20th century, massive cables that power light bulbs and keep us warm when it's cool and cool when it's warm, maybe with the occasional blackout. Despite their shortcomings and crowded atmosphere, more people live in the city now than ever before, with an estimated 4.5 billion people living in urban areas today. This number is expected to grow to well over 6 billion by 2050, which raises the question of how can we expand our urban environments without exacerbating the issue of climate change. Already, cities contribute around 60% of total greenhouse gases and 78% of energy demand. As these numbers rise with the population, will there be a way to satisfy the growing demand for housing and energy while also moving towards a more sustainable future? While there are potentially hundreds of ways to optimize urban environments to lower their emissions, there are two main sectors that have the potential to dramatically decrease their carbon footprint. These are by finding alternatives to cement production and by optimizing the energy use of pre-existing and future buildings. First, let's talk about cement, as it's something we're all familiar with and see on a daily basis. For those outside of the construction industry, the production of cement is rarely thought about. This process is incredibly carbon intensive, emitting 2.3 gigatons of CO2 in 2019, roughly 7% of all global emissions. This comes from the production of clinker, the main binding agent in cement which gives it its strength. To make clinker, calcium carbonate, also known as limestone, is heated in a kiln to produce calcium oxide. This reaction separates the limestone, leaving the calcium oxide behind for use in cement and releasing carbon dioxide as a waste product. And this only accounts for around 60% of the emissions from cement production. The other 40% comes from burning fossil fuels to heat the kiln, electricity consumption, and fuel for mining and transportation. Some of these emissions can be avoided by using renewable fuels, but a majority of the emissions coming from clinker production are unavoidable. Even with the best practices, there is no way to continue making cement without producing tons of carbon dioxide. This leaves building designers looking elsewhere for more sustainable materials. One of the most promising materials to replace cement is cross-laminated timber, or CLT. These are essentially timber boards that have been stacked in a crisscross pattern, glued, and hydraulically pressed together, creating an incredibly strong panel. The environmental advantages of CLT compared to cement are astronomical. First and foremost, the carbon emissions associated with CLT are near neutral, if not negative, depending on the type of building. This is because as the trees grow, they are sequestering carbon dioxide from the atmosphere in their wood. Additionally, the timber is grown in forests certified by the FSC or the PEFC for the purpose of sustainably harvesting timber. This way, CLT demand does not contribute to deforestation or biodiversity loss. CLT is also far quicker to assemble than buildings with cement, cutting construction times with year-round assembly regardless of weather. And if all these reasons were not enough to make cross-laminated timber a more attractive material, it is also fire resistant, despite being made of wood. When exposed to fire, CLT quickly chars on the outside, creating an insulating layer and protecting the core from burning. This can provide fire resistance for 30 to 90 minutes, depending on the thickness, slowing the spread of a fire and giving ample time for evacuations. And of course, the buildings look gorgeous, subjectively a more pleasant experience than the brutalist architecture that dominated the mid-20th century. By using cross-laminated timber to transition from cement and steel, we can safely accommodate a growing population while also reducing emissions from construction. The next step to lower emissions even further is to make these buildings more energy efficient. Optimizing energy efficiency goes beyond just replacing light bulbs and turning the heater down. By finding ways to reduce the energy demand for cooling, heating, and lighting interiors, we can both save money on utilities and reduce carbon emissions at the same time. One of the largest sectors for improvement is in insulation. On average, 25 to 60% of the energy used for climate control is lost due to poor insulation. By addressing this inefficiency, there's potential to save thousands of dollars per household and keep gigatons of carbon dioxide from entering the atmosphere. Today, the most common form of insulation is fiberglass, which is not only carcinogenic and carbon intensive to produce, but nowhere near the best insulating material. To measure this effectiveness, a metric known as R value is assigned to describe how easily heat can pass through an insulator. Fiberglass clocks in with an R value between 2.2 and 3.8 per square inch, depending on how densely it's packed. Now, a much more sustainable insulator that outperforms fiberglass in nearly every way is cellulose. This is often made of recycled newspapers, denim jeans, and other plant fibers, with an R value between 3.2 and 4.0. Its carbon footprint is also much lower than fiberglass, with roughly 30 to 70% less CO2 emissions per ton. There are other insulating materials such as Icynene expanding foam with an R value of around 4.0 and polyurethane foam, which can get an R value as high as 7. Utilizing these insulators effectively would mean dramatically reducing global carbon emissions, but by how much? And how much would it all cost? Let's imagine a scenario where 2% of residential and industrial buildings retrofit their insulation per year using low-carbon cellulose fiber. This would come at an upfront cost of $831 billion over the course of nearly 30 years, but it would also save $24 trillion in heating and cooling bills over the same time frame. Most importantly though, the carbon emissions mitigated would be enormous, with over 19 gigatons of carbon kept from entering the atmosphere. While it may not be as glamorous as solar power or electric vehicles, insulation has the potential to seriously lower emissions. Beyond massive infrastructure projects like concrete replacements and efficient insulation, small changes can be made to pre-existing and future buildings to further lower their carbon footprint. For example, LED lighting uses 90% less electricity than incandescent bulbs or compact fluorescent lighting. If LEDs become the main source of lighting by 2050, this could lower carbon emissions by as much as 17 gigatons. Smart thermostats could be another tool to lower carbon emissions by detecting when and where people are indoors and adjusting the temperature as necessary. If these devices were installed in just over half of households with internet access, they could lower carbon emissions by another 7 gigatons over 30 years. Solar water heating is another strategy to lower the energy needed to heat water by using sunlight to heat it instead. Installing solar water heaters in just 30% of accessible homes could reduce carbon emissions by an additional 14 gigatons by 2050. This goes to show that when fighting climate change, there's not one golden strategy to lower our emissions, but a combination of a lot of little things. To build a more sustainable future, society must collectively move away from the inefficient, carbon-intensive practices that dominated the 20th century. Using plant-based materials to build our urban environments not only looks pretty, but sequesters carbon from the atmosphere and puts it in the walls of our homes and offices. By combining these features with sustainable technology and renewable energy, we can create cities that cost less to operate, are healthier to live in, and contribute far less to the climate crisis. The days of cement and fiberglass have passed, and it is time we take the next step in designing the cities that will define the 21st century. Thanks for sticking around to the end. Comment your thoughts on the video and check out the sources linked in the description if you want to read more about the future of sustainable cities. If you like this video, make sure to like, subscribe, and share to support Planet Zero. I'll see you next time.